Any of the knowledge-based words, like if you need to think something, if you need to be a smart, can you be a smarter than computer? That's going to be the question, right? Going forward, because the computer is going to think you more than human. How the situation can be handled, what kind of best scenarios that can bring out. So that's going to be the AI side. Artificial intelligence is going to rule the world. And if you want to survive, like if you want to beat that, so we need to be smarter than that. Otherwise, we may be like one of the participants who try to use the technology, not to own the technology. Okay, so my focus is going to be just an overview about those three terms, and then I'm going to explain a little bit about algorithms. So you guys would have noticed, right? Like when COVID times, there will be multiple waves, right? So this next wave will be like this much people get affected, this much people. So predictions, estimations, how these things will happen, right? What kind of people will get impacted, how many people will get impacted, where will be the clusters will be formed. Those things will be like all information was derived from those algorithms. And then it comes as a news to you. When you're watching a news, then you will basically say, okay, this is the next wave is coming, this many people might get affected COVID. That's all come from this algorithm. Okay. So let's move on. The diagram here you can see. I just put a highlight here. All these AI so let's continue. So the AI, ML, DL, all these things are start from the basic mother nature, right? What is mother nature here? How is the nature connection between mother nature and these concepts? So all these technologies are comes from neural networks, right? You people might heard about this word neural network, and we already know what is neural. Neural is basically a biological element, right? Organic element. So something like human brain has that inbuilt for many years. Okay, so we try to use that concept to build those technologies. When somebody is touching you, when something you are looking, how you get attention, how that get processed in your brain, what kind of decision you're supposed to make based on that input. All those things are already inbuilt in your human body. Okay, your brain is trained. Your brain, when you're born as a child, you don't have anything, right? Your brain is completely blank brain. But when once you start growing, the mother nature basically starts building the algorithm, right? That's called reinforcement algorithm. The, the baby starts crawling, walking, and then standing, running. All those things are really happening through the algorithm building. It's all algorithm. It's all based on algorithms. We are trying to copy that into a technical world. Today, we will go deeply into that topics and then see how practically it's going to impact. If you are able to build such a machine that could replace the human, Okay, that could be smarter than human. So we may need to be, in order to make more intelligent on ourselves, we need to upgrade ourselves, right? I don't know how many of people aware of computer is like playing a chess against the computer. The computer can do a billions of calculations in seconds, okay, in billions of calculations. But the human brain is able to beat the computer. Supercomputer is lost to the human, right? So that means there is a lot of potential in our human brain that is unexplored. But this technology is going to explore them. Okay. So let's move on to the next slide. So this is one of the typical thing we will start with. Different types of names here. So all the names are interlinked with machine learning. So what is the machine learning? What is the human learning? Human learning is where the mother nature builds you that how to walk, how to crawl, how to stand, how to walk, how to run. The same thing we are trying to teach into the machine. So that's called the machine learning. The machine learning has a different parts here, right? So how do you teach the machine? You can teach the machine with the different techniques. It's all named as by ourselves with some context information. First one, supervised learning, right? You are trying to teach the kid how to walk, and you basically make sure that it is not going to fall. That's basically a supervised. You are supervising that action, how it's supposed to be. That's a supervised learning. The next one is unsupervised learning. Okay, unsupervised in the sense nobody is going to tell you how to walk, how to crawl, or whatever the things you need to do. But things will happen. Things will learn. How? That's where that unsupervised learning is come into picture. Okay, there is multiple applications need unsupervised learning. Currently, we are using a lot of applications in supervised learning. You guys also in practical everyday life, we are also part of using an unsupervised learning where there is no data, but there is some information you are trying to make out of it. The third part is a reinforcement learning. So machine learning has different learning. The third one is a reinforcement learning. How many of you guys think the rover which is sent by NASA or the rover which is going to send by the ISRO to the moon or Mars, how that's really flying or how it's surviving there, right? All these things comes from reinforcement learning because we don't know how the Mars will look like, we don't know how the moon will look like, but we sending a machine, that machine is able to navigate in that planet. How that's happening? That's all happening through reinforcement learning. We basically send a rover to the other planet, find it out how the situation, how it need to react, how it need to handle the things. Okay, if there is if Mars has a planet full rocky surface, how it's supposed to walk there, how it's supposed to roll there. It's all will be trial and error. Okay, note it down, trial and error. Things will not come easily. Things will happen on a trial and error basis. That's the reinforcement learning. That's where the kid, the mother nature develops. Right? Once the baby, it starts learning itself, we try to get a reward for good things, we try to punish for the bad things, and then it try to readjust its focus. That's called reinforcement learning. Okay. So there is other block there. That's a traditional programming, right? Before this 2020, let's assume 2020, most of the people might aware now chat GPT, right? Like you can go and ask some questions, it will tell you the very human way of answering the things. But that happened, that started in 2018. They start building the model on 2018. We realize now in 2023. Okay, so at least we know that now there is something that is possible. So before 2018, all the programming is usually we have set up rules. Okay, I want to do this, and this is the input, and you get output. Okay, so it's basically a rule-based programming. So you need to know what is expected and how to handle them. Especially when you think about autonomous driving, when you have a car which don't have a driver, then traditional programming is going to fail, because if the road is not as per expected, like Indian roads, right? Suddenly there is a cow crossing in a road, dogs running in a road, which you need to tell the machine that, oh, this happens, you need to do this. That's a traditional programming, which is a complex programming. That's what happening in 2018, before 2018. But now, after ChatGPT starts on, exposed to the people, everyone knows this side of the part now, the bigger part now. What is machine learning, right? So you can see multiple things based on that. Supervised learning has classification algorithm, like you want to classify male, female, good, bad. That's the classification. Okay, regression algorithm. You basically want to find out, okay, this is currently I have, how much it will become a bigger thing. Okay, I have a small code, like let's assume I have a population on this state is now currently 10 million. How it will be after 5 years? That's all comes in the regression algorithm. Okay, this side is supervised, unsupervised, has multiple things. One is the dimensionality reduction. There is a new algorithm. Okay, and then the other thing is clustering. If you have a camera, if you record the stuff, that's basically coming as a dimensionality reduction, where you're trying to compress on based on certain conditions. Okay, and then the clustering is where when you have a, like many people now look the Google recommendation engine, right? Okay, is this hotel is good or bad? So where that comes from? That's all comes from unsupervised learning clustering algorithms. Okay, how many number of people are able to give a feedback? You try to cluster them and then give you the recommendation. Oh, this hotel is good for you. That meal is going to be good based on other people's feedback. Okay, so let's go to the next slide. So I talked about the mother nature, right? So one of the things is what is a neural network? How the neural network comes to play in the technology world. So this side of the right side of this thing is how your brain basically handle all the information which goes. Whenever it receives the data, it won't react. It won't immediately react. It has a threshold. So if the information comes here up to the threshold, it won't react. Whenever the threshold happens, then the information will pass there. If somebody is just touching you, and if it keep on happening, your brain is keep ignoring them, so you won't react for it. But when somebody is pinching you, then your brain neurons get the signals hitting the threshold, right? It goes above the threshold, then the brain basically takes into action. A lot of such a threshold activity pass around to between the billions of neurons will make you to do something. What is that? You basically want to move away or touch it, react in a such a way that you are able to handle that pinch. Okay, that's the biology side. On the other side, you can see how that's mapped into the machine learning. There are multiple inputs. You have thousands of photos, and you're basically doing classification, whether it's a human or cat or whatever it is, right? So you basically have thousands of inputs that goes to the mathematical part of the neural networks. That's where you have a linear function which is trying to find out how much bias on that. Okay, you have 1,000 photos, and you are trying to build a system which is okay. If you give a photo, is this a human or cat? Is this a dog? And you out of the 1,000 photos, if you have 700 photos, is just a human. Basically, the particular input is biased towards the human side, right? Because you have more data set about human. So you also want to figure it out, those kind of bias things using a linear function. Once you know this set of information, okay, I have 1,000 photos, and this is the bias information about those things. Okay, I have 1,000 photos, 700 is human, 200 is dog, and 100 is cat. Now, if you really give a cat picture, direct cat picture, it might predict correct. When you have a different direction of cat picture, it will try to say, oh, this looks like a human because it biased towards human. So you try to say that, oh, this maybe it might be There are multiple things. Okay? What is the ground truth? What is the confidence level on this algorithm comes out, right? If it is 100%, there is no machine learning can claim it's 100%. Okay, it can say 99.99% this is human. It cannot say 100% because it learns from different informations. So the information can be diluted. So because of the dilution, it's never going to climb 100%. Okay. So here you can see the linear function. Other one is the activation function. Activation function is where the threshold is happening. As I told in the brain, when somebody is pinching you, you're going to react. But somebody is keep on touching you, you're just ignoring because it never reach your threshold. But somebody is pinching you, you touch your threshold, and then you want to react. Same thing is the activation function. When do you want to activate? When do you want to say that this is going to be a human, this is going to be an cat? That is the activation function. That's all mathematics. We are trying to use the mathematics, taking a biology concept, putting together, that's called a neural network. Okay? So can we go to the next slide? Okay, this diagram talks about, there are multiple things, right? Now we learned about neural networks. So what is the neural networks? That's a basic building block of this, all these technologies. You have a AI called artificial intelligence, right? That's a bigger box. That's like, can I define AI? It's a very big area. And within that, machine learning comes. Machine learning is one part of AI. Okay. The other one is the inner part is deep learning. So what is between machine learning and what is a deep learning? Is that machine learning is not a deep learning? So that's where that confidence level, ground truth, all those factors come in the picture. When the moment you say machine learning, there is a classical machine learning, deep learning. Okay, classical machine learning means you use most of the statistical formulas. Like if you have a statistics background, you will use a lot of statistical functions to find out the classical machine learning. But for deep learning, you need to understand each and every pixels in terms of image. Most of the deep learning purpose is basically when you try to train multiple images, figuring out, okay, this is basically a human or cat, and you pass the pictures. So it's trying to go pixel by pixel. If you have camera of 12 megapixel, right? So mega means 10 power 6. 12 into 10 power 6 number of pixels in the image. So you need to learn all those pixels. Each pixel has a 3 different color values: red, green, blue, right? So you need to figure it out. 12 into 10 power 6 of pixels color values. You need to know that. So that's called a deep learning. So you need to basically go after every pixel, every information of that. So you don't want to, even though it learns everything, it's still not 100%. Okay. So it's going to be a 99.99% accuracy of it's me. This person is Chandra. Okay. How much confident? 99.99%. Why it's not able to get? Because the learning it does not just only my images, thousands of images. Out of that, it learn about me. There is a dilution happening there. Okay. So there is a 3 terms. AI is a bigger term which includes the machine learning and deep learning. Okay. So the other picture talks about practicality of AI. When you are able to build a robot, that's AI. Okay. When you are trying to build these repetitive activity automations, okay, so you basically want to do something controlled by based on some event, and that event can be done through machine learning, but it's very focused on particular actions, activities. The third one is a deep learning. Deep learning is where you want to go every and other information. There is multiple information which you may need to learn. So that's a deep learning. So the deep learning is a core part. Outer layer is machine learning, and then the bigger part is the AI. AI is basically including machine learning, including software, including algorithms, including rule-based, unrule-based, conditional, everything includes in the AI. Okay, the next slide. So there are 3 different types of AI. Okay, so one is the artificial narrow intelligence. That means you basically want to do the intelligence on artificially, but for small set of activities. That's it. ANI, artificial narrow intelligence. The next one is general intelligence. You want to bring the intelligence on all other general purposes. That's called AGI. The next one is going to be an artificial super intelligence. That's where you might not have a military with a human. You might have a machines there. Machines will fight machines. That's a super intelligence. But as per this estimation, you see, 2040 is where we may, that's a prediction in 5 years ago. Artificial general intelligence is going to happen. It's supposed to going to happen in 2040, but now it's already happening. 2040 will be already a super intelligence. So the human might have a very less work, very less chance to prove them. So you need to be an extraordinary person to prove that you are best out of this. Okay. So what kind of implications? Already the existing narrow intelligence itself is outperforming human on specific tasks, not everything. It has specific tasks there, it outperforms. But when it comes to a general intelligence, it tries to take almost 60 to 70% of work away from us because it can able to do best things than us. We are constrained with a lot of other factors. But for machines, it's just an electricity and computation. For us, a lot of biological things in part of it. If you go outside in a rainy, you will get cold, right? Or fever. For the computers, it won't go and play in a rain. So that's a different story here. The third one is a super intelligence. That's going to be a completely outperforming than a human. It's going to be ruled by the AI machines taking a decision for us. Okay, can you go to the next slide? Okay, this is another way of explaining you. Okay, can you tell me where do I using a machine learning, right? On day-to-day things. So when you are having a like whenever you see that okay, you are looking for some shopping, you get an advertisement for you. You are searching something and then you see immediately you see that. So nobody is going to track you and every other moment. It's all collected information. They use the algorithm. That algorithm automatically going to take, okay, this is a target market. Oh, this guy is looking for shopping. Immediately the shopping related area advertisement will come to you, right? That's part of a clustering. Clustering algorithm is what applied there. They're trying to figure it out what is your interest, then they put together advertisement. Okay. And then if it is a recommendation, that's in clustering. Okay. When it comes to feature like structure discovery in terms of like what, like if you are a medical and if you have images and if you have a tissue directions, you like cancer, right? Nowadays the image itself is able to tell what kind of cancer. Those things are comes into the dimensionality reduction algorithm, classification algorithm, and then the regression algorithm. You are every day when you sit on the phone, that's what you are using in your images, in your photos, in your mails. Everything is based on the algorithms here. The last one is a reinforcement learning, where all these rovers, right, like Mars, Moon, whatever the people are sending, navigating there, everything is based on the reinforcement learning. Tomorrow, if you buy a robot for your home, it will automatically learn about rooms. That will be based on reinforcement learning. First time it will go to the room, okay, this is a hall, this is not a kitchen. Okay, it will self-correct it. And then it will apply the algorithm, that's called reinforcement learning. Okay, the next slide. Okay, so let's go into the little bit deeper on the algorithm side. Supervised learning has multiple algorithms like k-nearest algorithm, logistic regression, linear and polynomial regressions, naive algorithms, support SVM algorithm, and decision tree algorithms. These are some of the algorithms which really use on your supervised learning. When you try to, when you are having a Google Photos, one of the algorithm is used. So when you're, for example, places, locations, right, or items, like some items, you try to group together. Those are all comes from one of these algorithms. You go to the next slide, please. Next slide. Okay, so K nearest neighbor algorithm is basically, you see here the diagram. So it looks the data. So you dump the data, and then all the data is putting into an x and y axis. Like here, I call it as x1 and x12 axis. And then all the data is looked at in two-dimensional view, and then it will try to figure it out. Okay, that yellow, green, and orange, right? You have dots. It will try to figure it out whether they are near or if it is distributed. How can I group together? That's what the second part. Calculate the distance. You try to figure it out. What is the distance between one orange dot to the next orange dot? What is the distance between one green dot to the next green dot? That's the second diagram. You see that calculate the distance. Once it calculates, it finds the neighbors. Okay, who is my neighbor? Is my neighbor is as like green dot or blue dot or red dot, right? So it's trying to figure it out the neighbors on that. The third in the sense, fourth part of the step here is it will try to label them. Okay, now before that you don't have a label. Okay, once it finds out the distance, it finds the neighbors. Then I will tell, oh, I'm not like you, I'm different from you. Then it will try to label them. Okay, so this is a red label. This is a name it, just a name. Okay, the algorithm basically try to vote it. Okay, yeah, this is the longest distance but same category. This is the closest distance but different person, different category. That's where the voting is happening there. Okay, this is algorithm is used. Okay, where do this kind of algorithm is used? This is used in a pattern recognition, data mining, financial market prediction. If you are a stock market investor, you invest something, you want to buy some stock. That's where all these algorithms are used. Okay, intuition detection. If you have a computer, you try to find out whether there is some viruses in your system, right? That's intuition. If something is going to harm your system, that algorithm is also coming from this nearest neighbor algorithm. Okay, you will try to find it out. This is a good, this is a bad, what is the distance, how do I put it? All these things comes from this algorithm. Okay. Next. So another famous algorithm is linear and logistics regression algorithm. So you basically see the linear algorithm is a straight line, right? You have a two-dimensional between x and y. It will try to figure it out whether it falls that side or this side. Okay, this is a linear algorithm. The logistics algorithm is basically try to figure it out within a range whether it falls. It's not about x or y. Within where is that? Whether it's between this area and that area, right? So that's a logistics regression. Where do this kind of algorithms are used in terms of in the machine learning world? This is commonly used for the problems like a prediction. When you want to predict whether tomorrow's rain is going to come or not, right? You have basically a lot of information which already trained. So with that algorithm, you're trying to build a classification algorithm that's basically based on the linear and logistic regression. Okay, and also other places. Like you people might have heard that some bank, oh, there is a bank transaction flagged as a fraud. How that's happening? Like for example, you are always accessing your bank in Europe. Suddenly you trip to Singapore. You're trying to access it from there, your ATM card or a credit card. Then immediately you flag it as a fraud activities happening. That's through this algorithm because it keep on tracking whether this person is in this. It applies the linear algorithm to figure it out whether this is a known or unknown region, right? So that is data is feeding into that. There is nobody is going to program or this person. Okay, Chandra, this guy is using this credit card number or he's taking. Nobody is tracking it. Already the information is feed into the system. It automatically finds based on the activities happening there. That's some of the things like. Also, and another important thing is it also try to help you the anomalies, right? Sudden, you have odd people, right? Some kind of things happening. Okay, I have a group of things, but this is an odd man out. This is not the same as what I'm seeing regularly. That kind of things also using this kind of algorithm. We'll go to the next slide. So the polynomial regression algorithm is another interesting algorithm where you basically try to figure it out on a linear scale. Where is my points, right? Whether if you have a linear scale graph, and you have a points out below or outside, and then how much distance between them, how long from this linear distance. That's why you see the linear model, simple linear model. The polynomial model will look like when you have a polynomial graph, you basically try to figure it out the position of the activities. Okay, where is this kind of things will be used? During a COVID time, all these upcoming activities, right? Upcoming, okay, but there is a next wave is coming. This many number of people is going to get impacted. All these things comes based on this polynomial regression algorithm. That's the second graph in that. That's where the people were predicting, okay, how many people are going to impact in the next COVID wave. Okay, how that's happening based on the previous data. They're trying to draw the diagram and figure it out. What will be your next point? Whether it will be in this side or this side, and how whether it's going up or down, right? If it is next wave, it's going to be less impact. The previous dot will be higher end, and you will see the next one will be lower than that. That's kind of a predictions are used using these kind of algorithms. Okay, can you go to the next slide? So this is one of the famous algorithms. Most of the people will face every day, like everyday things in the sense when you go to the hospital, when you do X-rays, right? So you will see this kind of algorithms applied there. Okay, you will try to group them. Usually, when you have images, when you try to train multiple images as a classification algorithm, people will choose this because this is one of the best algorithm where you will able to tell, okay, this is a carrot. Feature extraction tells that human has a nose, dog has a nose, but a different shape. All those things comes from this kind of base algorithm. Okay, so where is this used? In your regular search, when you have a text, like when you're searching, right? You have a shopping. When you try to type shopping, automatically fills that search engine box, right? In the background, this is the algorithm is going to find out what's your going to type it. Okay, this is one of the algorithm where it also used for figure it out based on your activities. It will try to put your sentiment, right? Like sentiment analysis. When you go to the restaurant, when you put a 5-star for the restaurant, then you are basically giving you automatically the 5-star is translated into you like that restaurant. Okay, when you put a 1-star, then the sentiment will be like, okay, I don't like this restaurant. I have some displeasure on the restaurant. That kind of sentiment derivation is coming from this algorithm. Okay, can you go to the next slide? There is another algorithm. Many people in the like practical world, this is part of the everyday activities. Okay, support vector machines. So you basically have the boundary of decision boundary, and you have a data. Data is variation between this side and that side. How do you basically decide? Okay, you have a line, but your data is not really in the line. It's also either this side or that side. And you see that, okay, should I consider always comes this side, but next time comes this side? How do I basically take a decision, right? You have the confusion comes from that, right? So here, basically, that's where you see that how much margin between the decision boundaries. You see, you have this decision boundary, and between the margins, you are going to define, okay, within this boundary, I'm going to call this guy as X, and within this boundary, this is called as Y. So that kind of clarity, defining the clarity is what helping you there. Okay. So what will happen in between, right? There is a question of what is in exactly in the line. Then that's where it comes basically on kind of exceptional case in the SVN machines also provide to handle this kind of scenarios. Okay, that the SVN algorithm has those kind of handling within the boundary, same exact on the boundary, how many number of instances happening on the same boundary, and based on that, it's going to tell you whether you need to take X or Y. If you have always on the boundary line on X characteristics, and suddenly you see a one on Y, it will try to give you the X points because that's how the human perspective always right. Because you always familiar, okay, this is 80% is happening on this X in the boundary line. When suddenly one outlier comes, you will think that that may be wrong. But SVN will try to catch you that, okay, this is not wrong, this is different. Okay, so you will try to ignore those kind of things in a human perspective, but machine perspective, it will try to capture and it will try to tag them properly. So this is where do I use this kind of algorithm? Am I using daily? Yes, of course you are using it daily. And many of your classification algorithms like image, nowadays everyone tags your name, right? The image photos. Those kind of classifications, regressions of all these previous algorithms is already using an SVM. It has a decision. It's supposed to take its male or female or flower or bird, whatever it is, right? You want to try to classify the items. Obviously, that's going to use this SVM algorithm because you need to figure it out. Okay, this is a bird or animal, right? You have a classification, you give a picture, you want to tag them, okay. Tell me this is a bird or animal. Obviously, that has the boundary. If image looks like a bird, but it's an actual animal, right? Then that's where you basically comes in the boundary line decision making based on the ground truth, previous values, bias things. Okay, this looks the majority of previous learnings is similar to the existing one, then it will say it's animal. But if that's a bird, that's a wrong prediction. You need more data sets. Can you go to the next slide, please? Okay, there is another algorithm is a decision tree. It's kind of like you can see that decision node, there is a middle node, and then you have a leaf node. It's kind of a tree algorithm. Like you have a main tree, and then you have branches. Each branch basically have some branches. Okay, that's basically nothing but a decision tree here. And you need to look at here. All the nodes is not a decision nodes. When you end up in a leaf node, it's not going to make any decision. It's going to fall in either yes or no category. But when it comes to a decision node, it's going to be like, okay, either if certain condition is happening, you basically take it as a leaf on a no side or the yes side. Okay. So how do this is, looks simple for you for someone when you see this, oh, this is normal, right? This what is the purpose? You're really using this algorithm in every day. Where basically you will see that like some of the algorithms mainly in classification and regression tasks. In terms of regression or the classification, again in the image-based classification, image-based regression algorithm, they use the decision trees. At some point, you need to take a decision based on the group of pixels, that pixel information, which may help you to decide, okay, this is perspective of human, this is perspective of animal. Okay. Can you move to the next slide, please? Okay, so I put a couple of supervised learning algorithms, I think 4 or 5 algorithms. Those are the famous algorithms that we use in everyday life. Okay, in your normal phones, whenever you try to access some of the activities, recommendation starts, when you try to fill it out with the reviews, all those things are based on those algorithms. That's unsupervised learning. So now we are going to see the unsupervised learning where you don't have a create data, you are going to learn itself and based on certain conditions, again based on certain conditions, but not through the historical data. That's unsupervised learning. So you can see there multiple algorithms, singular value decomposition, principal component analysis, latent algorithms, and then the latent schematic, and then actually a growth algorithm, k-means, okay, density algorithms to means. So these are the couple of algorithms we unsupervised learning people will use most of the time. Okay, so let's go through and see how it's really used and where you guys, whether knowingly or unknowingly, you will touch this algorithm in your daily life. Can you go to the next slide? So here you can see like singular value decomposition algorithm. You basically will try to figure it out in terms of like what kind of, when you have the matrix here, right? You see that matrix diagram there. It will try to figure it out, exposing about different things in terms of like, okay, this is my matrix value, that combination of, you have multiple factors there, right? N and D and D power of P. So that each element of that matrix has a different properties. That property is basically making you the gap. When you look at the final matrix product, right? That doesn't tell you that this combination. But when you try to use this single value decomposition, you will try to look at from the different perspective. When you have the first diagram, look at the first diagram, the same thing, there is no change, but you are making it to a different direction. Okay, the angle of the V1, right? So that basically will represent the same thing when you multiply with a constant value, like a power of n plus m. Then you basically look at see that how it the same thing, okay, but different dimensions. That's where that dimension is captured on the matrix thing, matrix element with the different parts. like a red color dot, blue color dot, and green color dot. Okay, this is basically will tell you, okay, I have this output, but that output comes from the different information. That information is not on the same category. It comes from completely a different category. That's why the color means for you. Okay, can you go to the next slide? So this is a principal component analysis. This is one of the very important algorithm in every day. If you're an industry person, if you're working as a software engineer or machine learning, you will end up doing this either knowingly or unknowingly on this algorithm. Because when you try to choose something like, okay, can you come up with, for example, if you go to the one of the work I try to help there is in Coimbatore, right? Coimbatore, each signal you have a camera and it captures whenever the people is crossing the signal, it captures them. Okay, and then it will try to classify as a two-wheeler or four-wheeler, and whether it try to figure it out, group them known or unknown persons, right? Because it will try to tag, okay, keep person keep on breaking the laws. That algorithm is implemented there in Coimbatore. So when we try to do this, what kind of right algorithms we need to choose? PCA is one of the uh, like a kit, right? Will tell you that okay, this is a regression part, this is a classification part. So in this case, you can see that, right? When you have the jump of data, you will try to split them where it belongs to, right? Whether it belongs to this side or that side. That's again a classification. You are trying to classify them. How you're classifying them is when you don't know the anything. You have ton of data, terabytes of data. But when you try to look at apply the machine learning, okay, where do I start? Right? You put them into the bucket and then do the PCA, principal component analysis, and then try to say, oh, this is a regression part, this is a classification part. So that kind of view comes from PCA. This will be like one of the critical part of any software engineer who does the machine learning. They will end up doing that. They will start with the PCA, look at that, okay, this is a classification, I need to apply a classification algorithm. This is a regression, this is a polynomial. So all those you will get through the PCA. So again, how that's happening, it will put the data in, dump the data, look at them in a different dimensions, three X, Y, and Z dimensions, and or the two-dimensional view. So based on multiple dimensional views, you will be able to tell that where the data belongs to, how the data connections and its relations, and then it will try to pick right algorithm for that. So that's the PCA part. Okay, this is again I'm trying to reiterate that this is one of the very important piece in a machine learning world. Can we go to the next? So this is the new algorithm you can see here. Usually when you have the documents, right, you have dumped it, tons of documents, and then you will basically say, okay, what kind of document is related to what category? Then obviously this is where it comes in. This is going to be one of the key part in upcoming one, right? When you have the tons of Word document, and you basically have a, for example, I have like product description. You have a product description document. You have a marketing document. Okay. You have thousands of products, thousands of marketing, thousands of sales documents, everything in a folder. How do you classify them? So you apply this kind of algorithms where it will try to tell you, okay, this is basically a sales category. This is marketing category. This is a product description category. That's a very important part. This is basically you just apply, and then it will take pieces from there. It applies the LDA model where it basically starts building a parameter which is an alpha factor, and then it will try to find it out that parameter of parameter. It will look for the distribution of topics. How many topics here? Here is like a sales, marketing, product, right? Three different topics, and then it will try to figure it out the word topic assignment. Okay, what kind of words that used in sales document? What kind of words used in product description document? It will try to map them out. And then also, if somebody can ask a question, right? Does like product document will talk about marketing, right? How that will classify, okay, whether there is this algorithm, how it will succeed, those kind of scenarios. Then it will try to find out observed word. You see that W, right? There is a small box there. That's where its critical part will tell, okay, This is the marketing word, but it sits in the product document. This is sales word, but it sits in the marketing document. That's where it try to classify them. So this is one of the successful algorithm in the document classification. Okay, because it goes through the word by word, create a schematic map, and then gets the output. Okay. So can you go to the next slide? This another one is basically you can see that like latent semantic analysis algorithm. You have the documents and you have multiple thousands of words. How that basically from what kind of context it will derive the context of that particular words. If you keep on if the document describes something about the product, about the sales or about marketing, about ideas, that document is basically when you're trying to read the document, you will try to create a context. Okay, this particular document talks about autonomous car, how the autonomous car is going to drive, right? So after you read one paragraph, you will be able to tell what kind of context, right? Oh, this document is going to talk more about this one. That's a human brain, right? That it automatically identifies the context of a particular document based on some thread or based on some information. But this kind of context analysis document algorithm is really useful. Okay, and how this is derived? This is derived based on the study of human brain memory. Okay, one of the important part of like this is a mystery here, right? In a real world, nobody knows how human brain and memory works. There is no proper answer yet. Okay, you remember something, you forget something, you will recollect something, right? That memory is again based on some algorithm, nature, Mother Nature does that for us. And the way it does, it picks the memory information from your brain is very fast, right? It's in micro, milli, nano, sometimes nanoseconds based on your personality, based on your behavior. When it looks, when you, same thing, you store your photo in hard disk. How much time it takes for that photo to hard disk to the RAM to the screen, right? When you see them, it takes in milliseconds. From one place to another place to the display, then it applies the algorithm software, it displays you display. But brain is does it for you everything fast. This algorithm is derived based on the human understanding about the memory, right? Human understanding about human brain memory, how it works. Based on that, we come up with. There is nobody can claim that's what is really happening in the brain, but it works here. It works in the sense it try to derive the context based on certain keywords, repeating of the keywords that we try to apply with the way in the world. It's almost like you can see the definition, right? The definition of the formula. That's where we try to derive the context based on the multiple words it try to come out. When I throw the document, it should tell, oh, this is autonomous vehicle document. If I throw some other bunch of documents, it should tell, oh, this is a product document or sales marketing document. Can you go to the next one? There is another algorithm like a frequent pattern algorithm. So you can see like if you try to map the map, oh, this is keep on happening. How many times it's happening? Oh, every day it's 3 times, 4 times. Some bird is coming and every day 2 times. Another bird is coming every day and 3 times in some location. So you keep track of them and then put them into a chart, right? But in practical world, the same kind of a frequent growth algorithm is used in a like hard disk when you try to store them, right? 7-zip, like you have a zip file, you compress the data. So compression algorithm is based on this frequent growth. If it is same kind of repeated words in a compressed data, then obviously it will try to note it out how many number of times that pattern. Okay, so you will, that's where you are trying to compress them. You have a 5 gigabits of data, and you compress them, it becomes 2 gigabits, right? So that is basically applying this algorithm. This is again, you have a 7-zip and like almost like 15-20 years, right? Like you have a zip compression point. But this realization is happening in a different world also, like in the machine learning world, how this can be possible, right? How I can note it down and just use them in a later point. Okay, this is happening at 4 times in a continuous manner, then it will try to apply them in a later point. So you're trying to predict them. Oh, it's going to happen. It's happening 5th time. usually it happens in 7 times. So you can kind of making a decision. There is 3 more times it's going to happen. What is the probability? It's every day it's happening. That means 100% is going to happen. But out of 100 days, it happened in 80 days. Then you are saying, oh, 80% the probability that there is remaining 3 more instances going to happen. You get the point, right? Like something, some event is happening every day in 7 times, but currently it's in the 4th time happen. Then people might try to predict what is the probability of remaining 3 more events is going to happen. Can you go to the next slide? So this is one of the important algorithm again, K-means algorithm. So this is mainly used in a supervised, unsupervised learning, especially clustering problems, right? Okay, clustering is they trying to put a group of X. One when you throw the data, okay, this is our category of data are same. This category of data are different. You will try to group them. That's the clustering algorithm that uses K-means. Can you go to the next slide? Next slide. So basically last one of the algorithm means it clustering algorithm. So you can basically try to figure it out between the data when you shift that whole thing from one place to another place. How much distance, right? You can see the circle. Circle is moving from this direction. If you draw the x, y, z in a 3-dimensional view, you have the same data. You are shifting from one place to another place. That's the circle. You can see the circle, right? From previous place to this place, you completely shift and the finding of the distance. That's the mean set. You are completely shifting from one position to another position. Okay, so this is basically used in many of the application domains. Like if you are going for like security cameras, right? Security cameras, if you have a so you purchase some of the paid version of the cameras where it will try to predict, oh, this is animal, this is human, this is known person, this is unknown person. You can tag them, right? You known person, okay, this is my mom, right? You tag them and then whenever they cross the camera, it will tell you mom. If it is unknown person, then it will say that some unknown person is coming. Then you can set this what kind of activity that you want to do. You want to fire alarm, that's possible. So all these things are happening based on this kind of mean shift algorithm. Okay, this is where this algorithm is applied, especially in a security cameras. Can you go to the next one? Okay, so we end up with the unsupervised learning algorithms. Now let's get into the reinforcement learning algorithms. So I will go a little fast because this is purely a mathematics, and obviously I am here to explain you more because this is my one of the research topic. But let's move on based on the timing, right? So here you can see that like reinforcement learning has model based, model free. Okay, when you try to build the model, then it's obviously model based. Rovers, right? When you send something like NASA is sending a rover to the Mars. So that's basically a model free, and then it will try to apply the Q learning. Okay. So that's basically a model free because you cannot create a model, you don't have any information, but you need to build a model. Eventually, if you go on now check the rover, right? Then Perseverance, right? Perseverance is one of the rover which is sent by NASA, is still active. Now it become model based because it's already built the data. It has enough data about Mars. But when it lands, you don't have anything. So it's trying to apply Q learning. It will try to navigate based on the actions and rewards. It will try to learn. Can you go to the next slide? So this is a state action and reward state action. So you basically take a decision. You want to do an action, okay, based on certain conditions, right? And then that action is going to impact your environment, right? In the sense like you want to move, you want to move from X to Y. When you move to Y, what's happening in that environment? It makes some movement, right? In the particle movements. For example, in this case, I'm talking about Mars. The rover is moving from X to Y, and then in that place, if there is any rock or soil, whatever the composition is inside there, how that movement also interacts, right? If that is if that's not a smooth surface, then it need to basically try to reduce the speed. It will try to adjust. It will try to turn left or right, right? So all those actions is basically going to take it. The action is based on your environment, and then based on the action outcome, you are going to reward. Okay, I'm moving. The rover is moving forward. The path is smooth. It will keep on moving because it's getting a higher reward. If the path has some trouble in it, right? Then basically the rover is getting punished now. It won't get a higher reward. So what the rover will do, it will try to back it up and then try to turn right or left. See if the path is clear there. That's how this particular algorithm works. Can you go to the next slide? This is one of the another deep network where you trying to use the deep learning within the reinforcement learning. So that means that that model will always keep growing. Whenever there is something, a new information comes, you are trying to add them as a transfer learning part. Okay, I have a model. For example, let's assume we send a rover. We don't have anything at this point, but in Mars, we try to find the different obstacles, right, in the surface. Then it will try to connect them, create a deep view learning there. Okay, it will try to start building the knowledge out there, and then that based on that knowledge, it will still a reinforcement learning. It's not a supervised learning. It's not unsupervised learning. It's still a reinforcement learning. But based on the Q learning, it will try to use the model, and then it will try to build its own knowledge base. So that's a deep Q knowledge. Okay, deep Q network. Again, it's based on multiple factors. You keep remember the previous slide that basically based on the actions your agent is taking, based on certain state conditions, and also the environment where it actually supposed to happen, and then you get a reward. Based on the reward, everything is going to happen. That's how human we have tried to learn. It is how it starts crawling and how it starts walking, how it starts running. That's all reinforcement learning. Whenever it hurt, when you try to stand up, if it falls down, you just note it down the babies. It will be careful next time. It will try to figure it out, not to fall it again. It will make sure that it will try to find the whole place safely. It's getting there. That's the punishment. That reward it has low because it get paid. It fell down. So now the reward is basically low. When the moment it is able to stand up happily, then it gets high reward. Then it knows that okay, I can do this action. But whenever the moment it falls down, that's a lower reward. I'm going to do the same activity again. That's the reinforcement learning. This is one of the places where this world is kindly moving from. Because we don't want to keep training them, because training them based on the historical data is a biased situation. So you don't want to do that. You want to do the system to do it automatically based on certain reward and risk factors. That's where this comes from. Can you go to the next slide? Next slide. Okay, this is basically another algorithm in the reinforcement learning. There is a critic positioning, like basically always will give you the feedback. There is a feedback loop. That feedback loop is basically will tell you, oh, this is a good action, this is a bad action. So before even taking an action, you will get a feedback. After taking action, you basically get a reward, right? That reward will be high reward or low reward. But based on the reward, you are going to take next action. But the actor critic will suggest you that this reward is this particular action is getting a lower reward, but this same action will going to give you the higher reward at some different place. Right? So you understand, right? At some point of time you take some action. That action is basically giving getting hurt, right? If the rover is getting falling into some place, then you basically giving a lower reward. So what now rover does, what we don't want to move forward, you basically back it down. But that same learning, you as an actor critic, you are basically going to tell you that okay, this action can be repeated in different places. At that place, you will get a higher reward. Okay. This is another algorithm where this is one of the famous algorithm. Okay. So usually you have two feedback loop from the environment to the agent. You can see that, right? So you are taking a reward, like you investigate a reward from your actions, and also you are considering a state. At what situation and what factors make you to decide that kind of an action? Okay, you are including one more parameter. You are not just only giving you reward. Okay, yeah, this is happened because there is no path. the rover is fell down. Rover is basically not in a good situation now because that path is there is no path forward, right? So you basically telling you the system, hey, this action is bad, but this state is happening because of the state your action. So now the reward is low, not too low. That's the differentiation, right? You're basically introducing one more variable before you even deciding how much reward you want to do. Can you go to the next slide? Okay, so that's basically where reinforcement learning and just jumping a topic into a current trend. Like many people will know that like a ChatGPT kind of applications thing, if you are using some Google or Microsoft applications, right? So you will see that the NLP means natural language processing. How human context we are trying to make a word sentences, right? From the words to the sentence to the meaning, and then translate that meaning into into group, like concluding things. Okay, this is how it falls. This is what going to happen. So all these things are like human perspective. So this is basically here you can see that there is a different meanings here. NLU, NLP, and then ESR. ESR means automatic speech recognition. Okay. So NLU means language understanding, natural language understanding, natural language processing, and then ASR. So natural language understanding is how human brain is able to learn. If you're trying to learn Spanish, if you're trying to learn French, you're trying to learn English, you're basically trying to understand the word, context of the word, value you're supposed to use, that's all comes from your brain. So same thing we're trying to do with the machine algorithm called the NLU. Okay? And then it's going to respond to you when you ask some questions. When you ask the question in Tamil and you want to get an answer in Hindi, it's possible using NLU. Okay. Can you go to the next slide? This is basically where natural language processing started, right? It's not yesterday's development. It happened in long back. People have started this kind of concepts in 1948 itself. Okay, and then eventually you see that 2018 is where ChatGPT's first model is trained. They took all the words, they're trying to map a transformer model, creating in each word what it means, how it connected, what kind of scenarios it need to come. So it all comes in like almost like you can see 78 years of development here. It's not happened yesterday. And how it works, this part of thing, how human talks to the machine, right? When you're talking in terms of Alexa, or if you have a Google home or whatever. So you ask, hey Alexa, or hey Google, right? So in the sense, it starts listening there, then it captures your audio, and then it converts that audio into some text format. It will convert that into text format. That text format is getting into the machine process, like it will try to make a transformer tagging this element. Okay, what kind of K means what, Google, it will try to look from the alphabets also, like in terms of spellings as well. And then it will go to the data to audio conversion, right? From the data, you ask the question, what is the current time in India? Then it goes to the Google and that translates into the server. It try to query that, okay, now time is this. And then it comes back and then respond you back and the audio again. So there is a back and forth, text to the audio to the text is happening. Can you go to the next slide? Okay, this is another new word called the generative AI, right? Like many people nowadays hear this word very often. What is the generative AI, right? So I think very recently you would have heard them, like there is a company who laid off all the customer service employees. They basically ask them to walk away, right? Because they are able to put the chat bots in terms of if you call. Previously, chatbots will be very static. It will say hi, and then when you ask some question, it will basically try to connect with some human, but no more, right? It basically, because it understands, okay, hey, this particular valve is not working, and it will no need a human to listen that no more. So it's basically the bot can understand it because it already trained with what kind of issues it will come, how it's supposed to do. Okay, so how this tomorrow the for example, how the workspace, like when you guys finish your college, when you come back for the job, what kind of jobs will be available, right? This is going to define. Okay, whether the software engineering jobs still work, still valuable, whether human need to do the coding. This generative AI is basically going to take many part of those kind of questions. The answer will come from this particular technology. Okay, I already have the generative AI, you don't need to have the human there. Okay. So many of these business operations, everything can be automated through this kind of machine learning stuff. Can you go to the next slide? Okay, this is a continuation of the previous one. Okay, so you see that how this grading works. It works based on variety of information we feed into the system, not just image, not just text. Okay, you basically give you n number of things. Even if something falls on some noise happening, that noise is also part of the learning. Okay, so every morning you see that like the rooster is making a sound, right? That also will be a part of learning. It will also go there, whether it's morning or evening. This generative AI will know, okay, there is a rooster sound, it's a morning. Okay, everything will be learned. Everything, whatever you do is going to be a part of learning. So that's how it comes into that. Can you go to the next slide? Okay, this is another cool feature, like many of mobile phones in next year you will get this. Like you don't need to have a camera anymore. If you have an image already, you don't need to stand there and take a picture. You can just tell them, oh, I need a picture standing in front of Eiffel Tower. So because the system knows how Eiffel Tower will look like, how you will look like, and it automatically generates the image. So when we have a manual camera, that's gone. We have a mobile camera, that's going to gone soon. Nobody is going to give a pose for anyone. No, we don't need to do our makeup stuff. It's already happening. Okay. So here you can see that like the image already knows about cat, and the person is asking you to give you, can you give a cool picture about cat? Then the computer is generating a picture of the cat with its cooling glass, right? You can see that. That's a generated image. Okay, the next slide. Okay, so I think that's the last slide. Okay.